But basically, what I
Sure.
want to say is that your approach is actually fairly solid. Just needs to be refined and um, what's it called? You need to be faster. It just boils down to being faster, and I'm going to show you what that entails.
Hello.
Oh, hey, what's up?
Hi.
Hey, how's it going?
Good. Good. Is this Edbert?
Yeah, this is him.
Oh, great. This is Andrew speaking.
Oh, hey, nice to hear from you. So how'd you hear about me?
Yeah. I am a member of the Facebook group. I think it was Subtle Asian Tech,
Really?
and and I saw your Google Doc. I read through it. I was actually kind of laid off a week and a half ago. Working as a software engineer at a small startup. It's kind of a panic fire. And I'm now kind of in, I guess getting started with applications. I sent out a batch last week, and really aiming to get into one of these bigger companies with more job stability. I found your study guide really helpful, really kind of reassuring, I guess, in a way.
Mhm.
And I just wanted to clarify some of that with you, and just get a sense of kind of what the market actually looks like, and kind of what my approach ought to be. So,
I see. You say it's reassuring.
yeah.
So what do you mean by that?
It's just, I feel like there's so much just for some background on myself. I majored in math 4 years ago, but took a really unconventional route. Ended up doing a coding boot camp and was working, like I said, at a startup just before, I guess just up until 2 weeks ago. I had always felt like big tech companies were kind of like out of the realm of possibility for me.
Mm-hmm.
And at least from your article or from your Google Doc, it seemed like it might be, and that would that would really fix a lot for me. And but there's so much to. I feel like in tech there's so much to know. Like, to be perfectly honest, despite being in it for a year and a half, I feel like I've just scratched the surface.
Mm-hmm.
Um, so like kind of going into an interview, like it's helpful to have kind of a better sense of what I ought to be preparing for, as opposed to just like kind of feeling like vastly overwhelmed and unsure of what to study. Does that make any sense?
Yeah,
Or
that makes sense. Do you mean overwhelmed
sure.
in the sense of what the technology that's out there, or overwhelmed in the topics to study for the interview?
Yeah, and in the topics of things to study for the interview.
Mm,
Yeah, I right.
I see. So it's like it's the number of topics that you need to cover is not very much actually. It's equivalent to about, I would say, maybe 6 to 8 weeks of a college curriculum, but it's more in the realm of how well you can execute on these data structures and algorithms. So I don't know if you watch my YouTube channel, but one of the things I point out, the biggest thing that people get wrong about the interview is that it's not a college exam where you regurgitate definitions from a biology textbook or something like that. It's your ability to execute on these data structures and algorithms and apply them in a meaningful way that is not academically interesting, if that makes sense.
Sure.
Yeah. So when you're studying, what do you think you're messing up the most on?
Um, well, when I'm studying, I think what do I think I'm messing up the most on? Um, so uh, I guess could I
Yeah.
I'm not exactly sure how to answer that question. I mean, um, I guess one thing is I still feel fairly unconfident about going into an interview, and I guess that's sort of like a product of maybe not having put in enough time,
Mm-hmm.
maybe not. So I'm not actually finished with your study guide, right?
That's
I've
right.
finished. kind of all the problems, or at least I've done an initial run through of all the problems in cracking the coding interview, the patterns.
Mm-hmm.
Have not touched the dynamic programming component of that yet. I'm actually reviewing all these problems and
Mm-hmm.
actually trying to do the challenge problems as well. And I have a copy of EPI, which I plan to get into as well. But yeah, I mean, I feel like until I'm finished with those, I feel sort of unconfident about going into an interview. But there are sort of like external factors at play here too. And I was wondering actually, like you might be able to shed some light on this. Um, do you anticipate at least openings for these bigger tech companies to more or less be mostly open, like kind of on a continuous basis? And do you see kind of like the timing of when I apply to be particularly relevant?
Um. Okay. So so just to briefly, what's it called? I just want to note that my original question wasn't for like interviews in general. It was just like your what problems do you face when you practice these problems? But I'll answer that question. Um. So your question mostly seems to be around whether or not that you can get hired at these big tech companies and whether or not there'll be job openings. Um,
Sure.
I would say at the junior level, it's over the years it has gotten much harder and much more competitive
Mm-hmm.
to get those offers without doing substantially well on these coding interviews. Because
Mm-hmm.
like back when I was applying around 2015, 2016, it had
Mm-hmm.
just started picking up again. Because back in 2011, 2012, there was just such a high demand for the junior developers. And then you can imagine that over the
Mm-hmm.
years, people had just started applying to these coding boot camps, the just started graduating out of college or switching majors. And now the
Mm-hmm.
market is definitely much more saturated with junior developers. Um,
Mm-hmm.
so I think what matters more at this point isn't the
Yeah.
timing; it's just your ability to execute. Because Fang Mula,
Awesome.
like Fang Mula will always be hiring. Well, minus the unicorns, so really just Fang and plus Microsoft, LinkedIn, yeah. Any company that has been around for more than 20 years,
Yeah.
and is definitely one of the blue chips in the field will almost always be constantly hiring because it's just a
Great.
revolving door. It's just the nature of these companies.
Okay.
But so I would not worry too much about that, especially with Corona. Um,
Yeah.
it's we're gonna be here for a while, so I think it's very
Yeah.
pointless to think about whether or not the timing is right. You know, I
Okay.
mean, like the way I describe things right now is that if you're graduating college right now, you
Mm-hmm.
have the worst luck because people are just getting laid off and are
Mm-hmm.
applying to Google in droves. That's your competition. But I think
Sure.
once the dust settles in like about 3 4 months, the picture will be clearer and you should have a little bit less competition to fight for. But that
Okay.
shouldn't deter you from starting up from trying to do well at these interviews because you can either wait a year
Awesome.
and a half and not like until Corona's over and not
Yeah.
go to a top tier company, or you can at least give it a shot.
Yeah.
You know, because yeah, at this
Yeah.
point you have nothing to lose.
Yeah. I mean, my question surrounding timing. I mean, I really can't afford to wait like a year and a half. I mean, I can barely afford to wait like 4 or 5 months, to be honest.
Mm-hmm.
So my question on timing was like whether it'd be kind of like more expedient to just like, even though I don't feel totally prepared to jump into them now, or to study for whatever 2 months and take a crack at it then. But I think you've successfully dissected this problem, and thank you very much, into just like don't worry about the market factors, just get really good at these coding interviews.
Mm-hmm.
um, is that more or less kind of what you're saying?
Yeah, and if you're saying that you don't have that you only have 4 to 5 months, then
Yeah. So I yeah, I was really kind of the victim of unfortunate timing.
mm-hmm.
My unemployment got misfiled, and I made a huge purchase for my girlfriend actually the day before I got fired. So my runway is pretty limited. So I'm living very frugally right now. I mean, I anticipate having 2 months comfortably. I'm trying to stretch it to 4 months
Mm-hmm.
before I'm looking at taking out debt. But I think that'll be kind of a realistic timeline for me to be applying. I mean, if I have to kind of push it out and take on debt, that's something I'm comfortable doing. But
I would say it's almost not worth taking on that kind of debt just for those perks, just to try getting to a FAANG company. Because at the end of the day, you are still relatively inexperienced, so these interviews are still not like a great comfort zone for you. And not
yeah,
to mention, it might be harder to get these interviews. So I would not, if I'm in your shoes, I
yeah,
would not realistically bank on FAANG. I would definitely
sure.
try my best and just push my runway as much as possible. So that way, at the end of that runway, that way it gives me enough time to study, and it gives me, it gives me much time to study, so I have my best chance at making it. Because if you don't make it, they make you wait a year before you reapply.
Mhm.
So that kind of fucks things up for you. So I
Okay.
would definitely, if I were in your position, I would still try, but I'd
Yep.
be looking for other opportunities, at least in the short
Yep.
term, to keep
Yeah.
me sustained. Even if it's
Yeah.
like some no-name startup, as long as it pays the bills, you know?
Sure. Yeah. Yeah. I've got something like 150 companies, and they're broken down into 8 tiers actually, and I'm trickling out like each tier of applications on a weekly basis right now. I'm wondering if it would be kind of a good idea to extend that, but that's kind of and at least as far as applications go, I mean I tried internal like reaching out to internal recruiters and sort of like people within my network as far as like U Chicago or App Academy grads.
Mm-hmm.
Was not super successful there, but I think I do know, especially kind of on the lower tiers, at companies that I'm more interested in. I do know people who work there, and some of them have seen me have worked with me on coding projects before. So um, yeah, that's kind of my approach as far as applying goes.
I mean,
That's
I would not worry about tiers that in your position. Again, you're looking to take any job you can.
yeah,
Yeah.
yeah.
Do you need me
Okay.
to look at your resume later, or you think you're good?
That would be really helpful, actually. Yeah,
Okay, so we can do that
yeah,
after. So going back to the original question, um,
yeah. Sure.
sorry, let me make a note of this, of everything we just talked about. Okay, 45 months. Uh,
And I didn't say it at the beginning of the call, but thank you so much for doing this. This is this is like a real kind thing that you're doing during
mm-hmm.
quarantine.
Yeah, no problem. So, okay, so let's get to the technical portions.
Sure.
When you do these problems,
Yeah.
what do you struggle the most with?
So to be perfectly honest, the grokking, at least the coding patterns, kind of broken down for you, like the first 1 to 35 hours. The first problem I'll probably struggle with, and if I'm being perfectly honest with myself, I'm probably not giving myself enough time to struggle with it.
Mm-hmm.
Like 15 minutes is almost an upper bound that I'll like sit
Mm-hmm.
and kind of be frustrated with the problem before looking at the solution.
Mm-hmm.
From there, though, like moving on to subsequent problems here, I mean, especially like the problems are so derivative of each other.
Mm-hmm.
Solving kind of anything subsequently, and in fact, even a lot of the problem challenges are not especially difficult. This is with the caveat that I am sort of openly referencing, you know, past problems that I've solved when I do them. But
Mm-hmm.
so it may be better for me to put them to memory. But
Mm-hmm.
that's just been my personal approach. I have done a couple Pramp interviews and have done quite well on all of those actually.
Nice.
But yeah, overall, just kind of like establishing more discipline with my study patterns and trying to resist. I guess trying to like kind of consolidate what I'm actually doing. I mean, there are sort of resources galore, and I think I do mostly trust your guide actually. There are just there's some leak code problems that I think I'd like to flash at the end, and I think your guide even sort of covers that as well. So.
Mm-hmm. Okay, so you look at the solution too early. Yeah, that can be a problem.
Yeah.
Could I, if I asked you to write the bare basics of one of those patterns, could you do it?
Probably.
Probably. That's not. You should have that stone cold. Just
It should be yes. Okay.
yeah,
Okay.
it should be
Yep.
absolutely yes, unequivocally. So
Okay.
that's the first thing to work on.
Yep.
Okay, then let me be more direct. Let's say I threw a problem at you.
Mhm.
Where do you think you would stall? In what portion? Is it understanding what needs to be done? Is it writing the code, coming up with the design, coming up with a clean approach? What
Yeah.
is the issue?
Yeah. Coming up with brute force solutions has usually, I think part of the reason I do so well on Cramp is I come up with brute force solutions almost immediately.
Mm-hmm.
Sometimes my code implementations are not totally clean. Like my Python is not really where I want it to be. I'm actually coming from JavaScript, but
Mm-hmm.
figured that Python would be a better language to do this in.
I mean,
Um,
honestly, language does not matter. It should least your worries. Everyone says it is. It's not.
okay, okay,
Just do it that
um,
you're comfortable with. Yeah.
okay. But yeah, just like implementing kind of my idea in code is sort of probably my biggest sore spot. Yeah.
Okay. Okay. So then that I see. I think I know a problem to give you. Okay.
Okay.
So let's get into it. Let's see. By any chance, do you watch my YouTube?
I've been on your channel. I've not watched any of the like you've got sort of like case interviews that you've done.
Mm-hmm.
No, I haven't seen those.
You should. I recommend you do. You can that way you can avoid a certain mistakes. There's a lot of things I end up repeating, and I
Okay.
think it's like if you have time, maybe like before you go to bed, just watch the recap of me tearing the guy apart or some shit.
Sure. Okay.
It's like usually just like 20, 30 minutes at the end where I do that, and then I just walk through the problem with them, how I would think about it. I think you might get a lot of value out of that.
You think everything on your YouTube channel I should probably watch?
Well, if you can, I would say if you don't have like the time to do it, because I know you're studying, at least watch the recap, like my review of the guy at the end, because I that's where I point out his mistakes, and in fact, like you can even do the problem that I give them.
Okay.
So I think this is a pretty fair problem to ask. I would expect you to do it pretty quickly though. So, let's go. So, given a string containing only digits, return all the possible valid ID combinations. So, an IP address is consists of four integers, where the integer value is between 0 and 255, separated by a period. So, if I gave you that entire concatenated string, then these are all the possible IP addresses that you can parse from it.
Okay. Yeah. Okay. Cool. So I'm expecting as input it'll be a string, and for output I want an array of strings
Mm-hmm.
representing valid IP
Mm-hmm.
addresses. So guess what? Each integer is between 0 and hmm. So what's immediately coming to mind is I I think solving this problem dynamically would be at least one way to look at it. So kind of iterating through the string and at each position calculating all possible like IP addresses. You know, should we kind of insert a dot uh, at that particular position? So in this example, we would start at 2 and see that that is a valid integer, and then move
Mm-hmm.
to 5 and check whether that's valid.
Mm-hmm.
Uh, and then notice that it still is, and then move to 5 again, then realize that our final number would be this like gigantic thing, and then sort of backtrack. Um, that would so that's one idea. I'd actually like to think about the problem for a little bit longer.
Yeah,
Actually,
go ahead, take
I'm
your
not.
time. You get out
Yeah,
pencil and paper if you need to, and come back to me when you got an idea.
sure. So the 0.0.0.0 would be valid, right?
Mm-hmm.
Not sure I understand.
Wait, what? Is that Alexa?
0.0.0.0 would be valid.
Yeah, I guess for now. Although I've never. Yeah, it is. Yeah, that's considered valid.
Yeah. So I want to validate that my string length is greater than or equal to 4. You can get started, and also 255 by 3 is going to be or by 4 is going to be 12 positions, and less than or equal to 12.
Mm-hmm.
So that's an immediate validation that I can perform. So initially, I was thinking about going through this from the beginning, going at it from the end. So, iteratively, 0, 1, and 2 would be special values. Okay. From the back. So is there So I am a little bit stuck. I still have not found the solution that I definitively like over kind of taking a dynamic approach to it. Kind of as I described, going through each point and checking the rest of the string. The time complexity potentially. So and actually the solution isn't even perfectly worked out because I don't see anything better than that. And I want to at least present a solution. Let me try working out what that sort of approach would look like.
Sure.
And you can hopefully from that, I'll either find that the time complexity is ridiculous or maybe something else.
That's fine. Just come with a solution.
Yeah. So I suggested traversing it. So let's see, 255, 255, 111, 35. So, first checking that the string length is appropriately sized. This is kind of pretty affordable for us to do. And then, let's see. Yeah, so suppose we kind of like approached it, like I said, dynamically, but with recursion. Kind of like we would store 2 and then invoke a helper method on sort of the remainder of the string. So 5, 5, 2, 5, 5, 1, 1, 1, 3, 5, but this time breaking it up into 3. And oh, okay, yeah. So we would start with the first. Yeah, okay. Let's see. So I could check 2 and then kind of like helper on the remainder with how many, the remainder of the string with how many kind of, remaining integers are left to check, and then 2, 5 with the helper of kind of whatever's left, along with 3.
Okay.
And then be 2, 5, 5 helper on. Here we would get rid of 3. It should actually be. And then what our helper method would do is we would kind of see, we would have this leftover string with kind of 3 positions, and this 3 is just sort of like we're just passing this information along. And on this level, it would look like 5, and then helper, 5, 2, 5, 5, 1, 1, 1, 3, 5, and we pass in 2 now, and we do sort of 5, 5, kind of up until we're within our 2, 5, 5, 1, 1, 1, 3, 5, 2, and if we ever have a string, so if we ever have the value 0, so like kind of where we have our helper takes in like a string and a number of remaining ints, something like that. And if let me say just say a int count. So if our int count is, so sort of building the base case here, if our, so we know that we have a successful IP address when our string is valid, so from 0 to 255, and our int count is 1. Yep. Or another way to put this is if our string is empty and our int count is 0. So this is kind of our valid IP address. Okay. And we're not valid if kind of the complement of that is true. So invalid if string is anything and int count is 0.
Sure.
Is that sensible to you as a?
I understand where you're going with this.
Yeah.
Is there any other condition that you might run into in this recursion that could yield a false?
that could yield false. So we keep. So let's see, we are constantly decreasing the size of our string and also decreasing. So strings anything. So it's possible that in our validations, I could make these validations more robust by checking the remainder int count and validating that my string length is sort of reasonable. So string length is greater than or equal to int count, less than or equal to int count times 3.
That sounds a little complicated. Try thinking about what happens if you assume the wrong digits during your recursion. What happens then?
If we assume the wrong digits in our recursion, so this is like kind of looking at the case where we have like 2.5.5 and then this monster. Well, the monster, like, so 2.5.5, you know, what's left over is this big string of, and I'll paste it here at the bottom. This, I think we would be okay here, because we would check 2, 2.5 and 2.5.5, right? And sort of this remainder, and just return, just like, you know, return upwards there. And in fact, actually, this validation, I do kind of like it actually on my helper method, because it will, this like string length is greater than or equal to int count, less than or equal to int count times 3, because it'll actually like reduce cases where I have to like compute monsters like this.
Okay.
It'll sort of really.
Then let me jump in here. What happens if you, could you also have a case like this? What happens?
Here I would have, so I would have 2.5.5 ahead of this, right? So this would be kind of my.
Okay. You know, let me be more clear with this. So what happens if you assume 255? Like, let's say this was your input, right?
Okay, sure.
What happens if you assume
initial input?
What happens if you do? What happens if you get to this?
Oh, sure. Okay. Yeah. Here we have, we would have an int count that is not 0 and a string that is empty. Great. Yeah. So it's also invalid if string is empty and int count is not 0. Great.
Okay. Yeah.
Yep. And I wonder if that covers all of my cases. I think it does. I think it does, and I think I think implementing this validation will probably be fruitful to us as well.
Okay.
Do you so real quick on time complexity here, or do you want me to kind of code this up first, or do you want me to talk about?
First.
Like,
let's
okay,
yeah, just
sure.
get to the code of view. Seems like you have an idea about it, so let's see.
Sure. So we'll call this thing. So let me actually just kind of initially. So pass string and int count of 4 into helper method, which will recurse.
Sure.
And then at the end of this, and we also actually have to build a return array and probably pass this into our helper as well.
Sure.
So we will append to this. And then this is kind of in our main function. ultimately return the mutated return array. Okay. And then in our helper method, so we're gonna pass helper method string int count equal to 4 and return array. Okay. The helper method will take it'll first run this check. So check that string is greater than or equal to int count, less than or equal to count times 4. Then so I want to check my base case here. So if int count is 0 and string is empty, I want to append. Okay. So in addition to our return array, we're also going to need to keep track of our current current string. If int count is 0 and string is empty, append current string or current. I think I could definitely be a lot more semantic with this, but current combination. If int count is 0 and string is not empty, just return. If int count is non-zero and string is empty, return. Okay, and now we want to kind of build a recursive step. So we want to recurse. So we want to invoke helper method on so we're guaranteed. So invoke helper method on first string with first element removed, pass in first element to current combination, and I think the current combination I can store it as a so build a return array and pass this. Build a current combination and set it to an empty array. Pass in first element to and append first character. Pass in first character to current combination. Recurse on remainder of string and decrement int count by 1.
Okay.
Invoke helper method on string with first and second characters removed, and first and second to current combination. Recurse on remainder.
I get the idea.
And then, yeah. So
go ahead.
Invoke on first, second, and third if it's less than or equal to 255. Okay. And now I feel good about, and so ultimately, I'm going to have a return array that kind of gets mutated all along the way, and then I'll just be able to return a return array. Great. I'm going to get started coding here.
Yep.
So def, I'll define this as valid IP, and it'll take in just a string. And okay, so return r is equal to, is there any way to turn off kind of the automatic capitalization? Or
I mean, it's fine. Honestly, I understand what you're doing, and I don't know how to do that, dude. But go ahead. It's fine.
Sure. And then valid IP rec just kind of calling my recursive function on. Oh, I also wanted to build a current combination. An empty array. So I'm going to end up here with, so I'm appending, so I'm actually going to end up here with an array of arrays in my return array. I don't want that. I actually want, I want an array string. So I actually, so instead of if in count is 0 and string is empty, append current combination joined. So
Sure.
basically append the string.
Mm-hmm.
Valid IP rec will take in our string, our initial string at first,
Mm-hmm.
the in count of 4,
Mm-hmm.
return array, and current combination. We do a bunch of things to return array and then return mark. Okay. Def valid IP rec, and it'll take in string, int count.
Mm-hmm.
Is int count the best semantic to use here?
Just it's fine.
Okay.
I mean, you've already put enough context on it. I honestly don't care.
Sure. Combination. Okay. Real quick, just a validation check. So if len string, and actually I shouldn't be using string here, just because it's a protected word. So I'll use str instead.
Sure.
If len of str is, so let's see, if int count is less than or equal to, or if it's strictly less than, and int count times 4 times 3, just return. Okay. It's going to be no good. Yeah. Otherwise, okay, so that's my first. Then if int count is 0, 0, and len of string 0. Current combination dot append. Actually, let me just build this thing first. Valid combination is equal to current combination dot join yeah. So let me think here. So I'm going to be kind of appending to current combination characters, so strings. Mm-hmm. So current combination should look like current combination should look like 255, 11, 0, something like that. So I want to join it. You know what? Actually, I think I would be better off. So because I'm going to be, so I'm going to be passing in strings to this. I think I would be better off actually setting my current combination instead of an array, just concatenating.
Sure.
So valid combination equals. So actually, my current combination will basically always be kind of a valid return if we hit this case. So I just want to just append current combination, then return. And so basically, I want my return to look like 255.255.0.0.
Sure.
So something to keep in mind. Probably my recursive step as I'm building current combination. And what else? We got if int count equals 0 and len of string is not equal to, and I mean, I guess we could just check if there's Len of string, if it's anything but 0, it'll be truthy. So I'd want to just return. And if int count, so if len of string and int count 0, the string is not empty, int count is 0. Len of string and int count is 0 and string is not empty, return. Int count is non-zero, and okay. So if len of string equals 0 and int count also return, right? So so these are cases. Now I invoke my helper method. So let's say so valid IP rec on string at 0, or no, string from 1 onwards, int count -1, return R, and current combination dot current combination plus dot plus, yeah, wait, so no, current combination plus dot, well, so for my first value, yeah, so I'm getting a little caught up semantically here because I don't want to have like a hanging period here on my current combination.
Okay.
Which is why join would have been nice, but I mean, it's not going to be pretty, but I could just look if current combination. So if it's empty, then valid IP rec string 1 onwards, int count -1, return R. Plus
I don't think you need to do this. What if you
plus dot?
I don't think you need to do this. I think you could just get away with just appending it at back here.
No. So
oh, you mean if you start off as empty?
So
this is your initial case. I see what you're doing.
Append the current combination. So
I see what you're doing.
Append a dot and value, unless it's the first value. That. Okay. Otherwise, not, or if current combination or len combination is equal to 0, do that. Otherwise, oh, and actually, I also want to do this on string from 2 onwards. Int count -1, return R, current combination plus string 0. So, and then here, if 0 to 2. So if string from 0 to 3, and I actually have to check if the so I need to check the int version of this. So dot I don't know off the top of my head the Python like way how to kind of transform a string into an integer, but Can I
Yeah, just I can assume
just to
that.
end?
Yeah, something like
Okay,
that. Honestly, I'm not a Python programmer either,
cool
but
that.
it's like it's just a little thing.
Edbert?
Yeah. Hello.
Yeah.
Hello.
Um,
Wait, can you not hear me?
oh, sorry, Edbert. I think I might have muted you. Are you still there?
Yeah, I'm here. I was wondering if you can hear me or not.
Oh yeah, I was muted for I don't know how long actually.
Okay, yeah, I was like
So-
saying something, but I'm just like, oh, you're not responding. Like, okay, it's all good. But yeah, you can do that. I honestly don't. It's like it's a small thing. Go ahead.
Okay. Yeah. Oh, geez, sorry. I just got this new MacBook with the touch bar.
It's all good.
If this is strictly less than or equal to 255, then I can do this. Valid IP rec string 3 onwards, int count -1, return our current combination plus string from 0 to 3. And then otherwise else. Basically the rest of this except for so basically it's the same except for I want to append a dot here.
Sure.
Let's see. Geez, Siri. So wait. Else, if the length of the current combination is not equal to 0, that means there's some character there, and I just want to append a dot. And the current combination should look like this, which it will. My int count will go down to 0. My return array is receiving current combination, and I should get down to one of these 3 base cases. So either my int count will hit 0, and I'll have something in my string, or my string will hit 0, and I'll have something in my int count. Let's see. Is there a case where my string hits 0 and I don't have an int count? Well, I could take care of that here. So yeah, so I don't need any return after this. If I've coded this properly, I should always hit one of these base cases, and my return array should continually be accepting, possibly accepting current combinations. And just looking back at this, the prompt, I want to return an output of an array of strings. If there are no valid IP addresses, returning an empty array is okay.
Yeah. It is not valid.
Yeah. Okay. So that's a solution that I came up with. I could do a time and space analysis if you'd like. Yeah. Sure. So the time here. Well, let's see. So we're doing. We're iterating through. At least every string in the character once. But so yeah, the time complexity here will be sort of tricky. So So we are we're making 3 recursive calls here, essentially. And at each recursive call, and we do this for let's think we're arbitrarily large, and so we could call that 3n. So 3n calls, and at each recursive call, we have this sort of nasty slice function here. So 3n, and that's going to cost me again n in time. That slice, so 3n times n. I do have this eager return, and I wonder if that cuts down on my time here at all. In fact, I think it does, actually, because for arbitrarily large, yeah, I think it does. So, I mean, one could make an argument that I'm only iterating through. Right, because if I ever, so this helps in the case of large strings. And on large strings, if big, still. So I wonder if, I mean, could I make an argument that my, at least my time complexity is going to be bounded by the fact that IP combinations can only be length 12, and I mean, I think there is a, I think there's sort of like a argument that for sufficiently large n or input sizes, that my algorithm actually runs in constant time. I mean, like worst case with an element, like our worst case is an element with so have four int counts, right? To start with times 3. So our worst case is actually an input size of like a string size of 12 characters. And with 12 characters, we are we're doing, how many computations are we doing here? Oh well, we're still making the recursive dive into each of these. Sorry, it's an unusual error because I haven't seen this one before, and it's a very interesting problem, but just kind of wrapping my mind around it. So my largest potential input size is 12. What I'm doing is I'm making 3 recursive calls on for each character, and I'm doing that at most 4 times. Yeah, because my int count is decremented at each level. So imagining 12 as my input, so let's call that n. Doing n of these. In fact, doing 3n recursions. I'm not actually. I'm doing 3 recursions in the first level. Oh, geez! there's sort of a convergence here. I'd have to really step through it. To 12 becomes 11, 12 to 10. Um, 11 to 10. So actually, I don't have to do all those. I mean, I could do 9. We'll go 11.
We're coming up on 42 minutes, by the way. Just let
Yeah, that's.
If you want
I
to throw in
know,
the
I know.
towel,
I
if you want to throw in the towel, then it's fine.
Sure. Yeah. Yeah. So basically, what I would have done for the rest of this problem is, if given more time, I would have kind of worked through the example here just to find my worst case time, like how many reversions we're doing. I think it converges to something. I'm not exactly.
I'm going to tell you exactly your time space complexity. Your time is constant time, and then your space is constant time.
Okay, cool.
All right. So let's stop recording. I'm gonna replay it back to you. All right. So, how do you think you did?
Yep. So I think I did. Not great, but I think it was a salvageable interview. I thought I kind of expressed my thoughts pretty well for a problem that I had no idea how to solve. I think I came up with a working solution. I think I went through my solution at least once since I had it finished and at least didn't notice any bugs. There might be some. Would I pass myself for a top tier tech company? I don't think I would. Yeah.
Yeah, I think that's pretty good self-assessment. I'm sharing my screen right now, by the way. But basically,
Sure.
what I want to say is that your approach is actually fairly solid. Just needs to be refined and, what's it called? You need to be faster. It just boils down to being faster, and I'm going to show you what that entails. So let me see if I can. Yeah.
And you may or may not be putting this on YouTube.
May or may not. I think this is something that, don't worry. I usually edit out people's information anyway. So.
No, I'm totally comfortable with that, but I'm just curious.
Yeah, I think this is a good one to put on YouTube. I don't put everything on YouTube, to be honest, because I think there's some people who, when they solve the problem, they just offer nothing new. You know, like they just like straight up struggle with it so much that they're just too much to focus on. That I don't think people are actually going to learn from it. So I don't put those on. Okay. So anyway, so here you are. Starting off, it's fine. Going through my notes. So at 2 minutes 24 seconds, you kind of mentioned that you want to do this dynamically. I'm going to tell you right now, dynamic programming is probably not possible or efficient for this because dynamic programming implies that you can reuse a previously computed answer and build upon that. Except the fact that if you found a valid IP address, you found 4 digits, like 4 digits here. So any remaining ones that you find after that can't possibly be used. So once you found the answer, you can't build upon it.
Sure.
That's why. So when you first said dynamic, that got me the heebie-jeebies. It was a small thing, but I see that you didn't commit to it, but it's just something to keep in mind.
Yeah, sure.
Okay, so then here, 354. Let me see if it will play. Give me a sec. Not cooperating with me right now. Weird. Let me try that again.
Just curious, and if I'm interrupting you too much, let me know. I would be interested in recording myself going forward and just like kind of giving myself these sort of like pressure, timed examples. What software are you using to record this?
OBS. You can also do it with what's it called? QuickTime as well.
QuickTime. You said you're doing it with OPS?
OBS, yeah.
OBS. Okay, great.
Yeah, here, let me restart VLC.
Great. I just get myself a rubber duck and walk through problems like this.
Yeah.
I'm sure I would totally cringe if I listen to myself, but
don't worry, everyone hates the sound of their own voice and how they perform. That's like I literally just did that over and over and over again. I was like, fuck this.
Yeah.
Okay, VLC is not responding. Give it a hot second.
Gosh, that Mac Touch Bar is like really. Do you use a MacBook Pro, or have you used one?
Yeah, that's pretty standard issue for anyone in FAANG company, and I worked at Apple previously, so yeah.
Yeah, I don't know how long I was muted for, but that, and I kept hitting Siri too. So, but also I was like tremendously nervous.
It happens.
Fumbling over my keyboard.
It happens, man. But the more practice you get, the less nervous you get, so it's all good. Okay, there we go. Cool. We're back in business. So around 354, you start establishing your bounds. Yeah, here. So I think this is completely fair. I think. I kind of like this. It shows that you're kind of limiting the problem to what you want it to be. Ideally, your code would be able to handle this innately, like without having to do explicit checks, like what you did in a perfect world. So that's just something to keep in mind. I'm not against this, but just keep it in the back of your mind.
Sure.
All right.
Tangibly, how would that look? At least in the context of my current solution.
In the context of your current solution, I would set this up as a test case, and then apply it after. So that way, my code should just be able to handle any string or any length, and then I'll go back and take a look, and then upon review, then I'll just try and figure out what approaches or things I could have done that would allow me to handle this, if that makes sense.
Okay.
So, the next thing I want to point out is around 740. All right, so I think you were trying to mill around for the dynamic programming solution for a while.
Yeah.
Before you decided to say, you know what, screw it, I'm just gonna go for the naive one.
Yeah.
I'll tell you this: almost no one gets dynamic programming right off the bat unless it's a problem that they've seen before.
Okay.
Like, if you got coin change problem, you would instantly know dynamic programming. Otherwise, dynamic programming is something that you would develop based off of seeing the recursive version of it first. And this is what you want to do. So, like, here, the point I'm trying to make here is you burn about almost 3 to 5 minutes just trying to be fancy when you could have just been simple first.
Yeah.
And even as I pointed out, the dynamic programming solution doesn't even really work.
Sure.
So, and small thing. But those minutes add up.
Yeah, sure. I mean, that really, I don't know if a naive solution would have passed an interview here, but I think I could have had like a pretty clean example and like properly analyzed it, and it would be professional and everything if I didn't fumble around it. And I was also like nervous because like, oh fuck, this is like a solution that doesn't work or anything.
It's fine. So, I'm going to tell you that most of the time, if you come with a naive solution, then you point out the places where you need to change to become an optimal solution. The interviewer will just be fine with it. Or they'll just straight up tell you, like, oh, if your naive solution is way too far off, that they'll just tell you, oh, there's a better solution. So honestly, you really can't lose when coming up with a naive solution. You just need to be faster at it. Okay, so then here, you are going through your cases. You're just going through an example. I'm cool with this. I like this a lot. It's like you come up with you have an idea in your head. You're taking the first 1, 2, or 3 characters, coming up, and then just doing the operations on them. Fine. This is absolutely good. And so now you get to this point, and then I have to so then I think around 12 minutes. 12 minutes to 15 minutes. You're trying to struggle with what other cases that you can come up with. Well, here your 4 cases are: you have a string. It's like you have strings that are empty, string not empty, int count that is 0, int count that is not 0. Those are 4 possible combinations that you come up with. So, if anything, you should just be thinking about those 4 possible combinations in here instead of trying to think about it outside of your function. So, you kind of do that. So, you have your int count is greater than 1. Valid IP if string is empty, or int count is 0. String is anything, and int count is 0. So, you have the int count is 0 cases covered. Then what happens if the int count is not 0? What do you want to do in those cases?
either keep recursing or check if my string is empty, basically.
Yeah, basically. And so those are the only 4 cases that you can ever run into, and you can't handle those 4 cases. Then your recursive function has handled everything that can possibly happen.
Right.
So, but instead, I had to basically give you the hint around this time.
Yep. Yeah, and you gave it to me, which was, I guess, nice of you. I don't know if I could expect that in an interview. But...
Yeah, that's a freebie. I just like, you know what? You already had an idea. I'll just guide you. It's like I throw you a bone. I'm not gonna count it against you, but I wouldn't rely on it if I were you. I would definitely at least tighten this up and just focus on the possible cases I can run into. So you kind of saw how, like, with those 4 combinations, I can prove that my algorithm handles everything.
Mm-hmm.
So that was like another 3 to 5 minutes, about 3 minutes wasted there. So you'll see, like, when I do these problems on my channel, that I actually do exactly this. I look at the possible 4 cases that I can run into, and then just prove from there that my recursion can handle it. Okay, so here you do your pseudocode. That's fine. So from 18 minutes to about 25 minutes. I'm actually 23 minutes actually. 22? Yeah, 22 minutes. Okay, so 4 minutes on the pseudocode. I'm actually fine with this as well. I don't think there's any. The only thing I would say is this. The comment at the bottom. This can be tightened up into a for loop.
Yeah.
So,
yeah.
So that would save you about like another minute there if you could just recognize that this is a for loop. This condition here. I'll talk about these comments later. And I'll just tell you how I would have done it. But these are just mistakes I'm pointing out. So this one, if you clean this up, that saves you an extra minute of typing. Because look at how much you type here, and then like 30% of it is just dedicated to this right here. That is basically the same exact thing.
Yeah.
So there's another minute right here. So let's go. Here you're actually writing the code. So you started up at like 22 minutes to write the code. And then you start second guessing yourself for the combination.
Yeah.
So here, I'm gonna tell you that you could just get away with the list, and then just once you have that list, then you generate the string from it. So the thing I didn't really understand is, well, you could have just checked for the list length, and if the list length was equal to 4, then you just just call current combination dot join with a period delimiter, add that, and then be done with it.
Yeah, if I join, so if you take a look at my current combination here with strings, if I join an array of strings, it like that works, like with a dot, like 255.255.11.0. That would, if I invoked dot join period here, that would give me what I want.
Wait, let me open the doc again. Okay, so yeah. So if you go ahead.
Oh, so let's see. Your current combination. Is this my?
I'm opening the doc that it exists right now. What I'm saying is that if you just added that check in here, like here, this is my.
Oh, sure, yeah.
So if you added just if cur combination dot length equal to 4, then just cur combination dot join, and then add this to your return array dot add. That skips all this shit here, actually.
Yeah, like my fucking else with everything. Yeah. Right.
So if the moment if you did this, your code would become so much more compact.
Yeah.
But instead you kind of end up mucking around with that, and it wastes a lot of time and this space. But you notice, like, the moment I just did this, it made the code so much cleaner.
Sure.
So let me see if I can just do a strike through on this.
Yeah, you just need an and count is equal to 0 on that, but
yeah, something like that. But but you get the point. So
sure. Yep.
I just
I mean, this is sort of like my coding is some work to do for sure.
Yeah. Don't worry. I'm gonna tell you how to actually get it better. So
sure.
Okay, so here you second guess yourself, and then you just decide to add the postpend operations, which again, well, I'll teach you how to recognize this later. But okay, so you're going through your cases, you're reflecting whatever is in your pseudocode. That's fine, but I think you're just taking a little too long with this, because if the way you wrote the pseudocode, you should be immediately writing this if statement like in like 5 seconds or less. But it seems to me like your pseudocode, the way you've written it, is not immediately obvious. So I would have just gone with something like length of string does not equal 0, just to keep in line with pseudocode. Or length of string equals 0. but then you kind of end up with this. So I'm like, why? It's just wasted time. That's it.
Sure.
Okay, so here, you start recognizing, oh shit, I need to be able to handle the case of when the current combination is empty.
Yeah.
And then that leads to your whole thing here. But you notice, like, I started you at 28, and then you have to spend 7 minutes.
Yeah, the rest of the problem is
Yeah, like 7 minutes
like,
just like literally doing this shit.
right.
Yeah. Instead, what you get done is just do this as like a for loop instead.
Yeah.
And then just add every single for loop if if it's a valid integer, then it would have been fine.
Yep.
So it's just making your code compact, and then work on the time space complexity analysis. So overall, if we just took out like all the inefficiencies, you save yourself anywhere 6, 7, 12. You save yourself about 15 minutes. So instead of this turning into like a 35, 40-minute problem, this turns into a 25-minute problem, or even 20.
Yeah.
So let's go back to the doc. And of course, like so let me.
The time complexity is I really struggled for a while on that. What were your thoughts on my time complexity analysis?
I'll definitely get there. So first of all, this one I would not do, because this has no added information, and it's also a little bit confusing under what conditions that this applies. I would have just said if int count equals 0, then I'm out. Or in fact, you could just put this in here. Ah, my mouse is fucked up. Let's do it with the keyboard. Like this.
I'm sorry. That shouldn't be int count. That should be length of string, actually.
Wait,
hold on. No, I'm sorry. No,
I'm doing this as a list.
But
or size, if this helps. But you get the idea.
Yeah.
So this basically does exactly the same thing. This is your code, though.
Yeah.
And so I just didn't understand why you did this, only because like even look at it now, can you understand what this does?
It's like making sure that the string is like big enough, like to be valid, right? It's like
Sure. Sure. But is it absolutely necessary?
Right. So you're replacing it with int count is equal to 0. Combination. I think it
because between what I have up here, between like this check and what you have down here, is it necessary?
Sure. Yeah. I think it is. I mean, for like gigantic, like, am I not saving a bunch of computations doing that?
You are saving computations, but what I'm saying is that this statement can be more compact. So let's actually go through it. So this upper bound here, int count 3.
Yeah.
I mean, technically yes. You're just only taking the last the 3 strings here, right?
Yeah.
So I'm just gonna have yellow's a terrible color. Fuck.
Wait, these are not equivalent. Int count times 3. Yeah.
No, but what I'm saying is that I see. I mean, okay, but let me see if I can rephrase this. Actually, I see what the confusion is. Yes, you are saving yourself you're saving yourself a lot of computations. But if that's the case, then why not if you're handling all the possible cases, your int count is going to be 0. So in this section, right?
Sure.
So if your string is arbitrarily large, right? Let's say it's like 1,000,000 length or whatever.
Sure.
You're only going to ever count. You're only ever going to do the operation 4 times.
Sure.
So, do you need to establish an upper bound?
Yeah. So right. Okay. I see what you're saying. I'm actually getting from 4 times 3 actually 12 to 4. Right. Yeah. Okay. So it's a constant time that I'm saving. Right. Mm-hmm. I'm not saving.
No. What I'm saying is like, okay. So your int count eventually becomes 0, right?
Yes. Yeah.
So you're already handling all possible combinations here.
Yeah.
why do you need so then why do you need this?
Because on in counts of 4, 3, so on 4 actually, like if my string is just like if my string is anything bigger than 12, I have like I just do one operation, right? And then I know I'm done. So that's sort of early on in the algorithm. But kind of like as you step through it, like 3, if I'm bigger than 9, like I don't have to, I suddenly don't have to do all those computations. Like, so I guess it loses some of its saliency like after 4. But I think on 4, it's actually crucial.
Okay, that's fine. I mean, you can make that argument, but you're only saving. But again, because your algorithm runs in constant time, you're just going to be saving yourself that, which is okay. But I would never put in the recursive function only because it implies that that is going to happen every single time. So in other words, like as you have mentioned, it loses its meaningfulness after the first iteration. So then, if you're going to do that, why not just do it up here?
Yeah, sure.
So that is it's just unnecessary information that doesn't add to your function, and it's just like.
Sure. Yeah.
So I'm gonna highlight this in red. So if you really want to commit yourself to that, then. So now you have your int count is equal to 0. And then because I did this you don't necessarily need to do this anymore either.
Yep. Okay.
So this can go away. How about this? Let me just copy your code just for the sake of like preserving it. That way we can see the difference. Okay, so I'm gonna do this on my code. I'll just highlight everything in red in here. Okay, so because I did this step, I can chunk this out. So all these 3 functions just go away.
Okay.
Because what's it called? You have these 2 cases here. In int count, you have 2 conditions: either the length of string is 0, or it's not 0.
Right. Yep.
And in both these situations, I've handled it. So this goes away. Now the only thing left is to make this section here of your code to be nice and compact. So as I mentioned before, I can do this and I don't actually even need to worry about this anymore. Because I'm going to do this as a list.
Sure.
And I know that if that list is valid as an input, then I don't need to worry about coming up with these cases. So that means that for int I equals 0, I less than or equal to 3, I plus plus, and then you get the idea, right? str if r I. Recurse with substring.
And you don't see a way to do this without slicing.
What do you mean?
Like slicing, like building that substring with. I guess I could do it with indices too.
Yeah,
that's sort of an option.
Yeah, I mean you can do it. You can do it with indices as well. I think if I remember right, in Python, if you substring it, you do a deep copy of the string. So you can do it with indices. That would save you on memory complexity, and I think if you acknowledge that at the end, I think the interviewer said, "Fine, whatever." Like he kind of understands. But as long as you got the basic idea down, then you're good. But what I want to show you here is look at how compact that code is compared to what you have. Yeah. That's it.
Totally.
Like this is beautiful and this is like readable as shit,
Sure. Yeah.
And then like yours, and it does like pretty much the exact same thing that yours does. Just in a whole lot less.
Yeah.
So it's like I boil it down to like 7 lines or 7 or 8 lines, and then wait, where'd your code go?
You deleted it.
Fuck. Yeah. I guess no. I put it at the top, and then I'm at the bottom.
Okay.
Yeah, I'm at the below. But you see, like the difference between your code and my code is that I don't handle like this weird case, so I don't have like all this verbose code going on here. And even if you did this as a for loop, you still have to handle this weird case down here. And I'm going to tell you that usually handling weird cases like this almost always ends up landing you into trouble. And that's a mark of a junior engineer, because this is like telling me that you don't think ahead in your code. You can't do what we call. Are you familiar with the single responsibility principle?
No. Sure. Yeah, actually, I mean, it's sort of self-explanatory, but yeah. Sure.
Yeah, each section of code or each object should handle one thing and one thing only. And here, your recursion handles both the appending of the dot and parsing the string to go into the next function.
Right.
And that leads to that, and that pretty much leads to your headache.
Yeah.
So, and if you recognize that you could just transform the list, a valid list, into the thing that you want, that would save you so much trouble.
Right.
So, hopefully that makes sense, and then hopefully that helps you in the future.
Cool. Yeah, definitely will.
Okay.
I think I could probably in my pseudocode is probably the place to get all this sorted out. Actually.
Pretty much, yeah. So first of all, as I mentioned before, make this more clear.
Yeah.
Because if statements should be very, very easy to write very quickly. Here, actually, let me just change my text to red, so that way I'm not. Again, like if statements should be very, very easy to write, and in fact, like you should see that in this int count here.
Yeah.
You should be able to combine this into one statement because this if statement up here is the same.
0. Yeah. Yep.
So you can combine that. You can combine that into one statement and make it more compact, which is essentially achieves what I have here. And then this one should just never return. But yeah. But yeah, let me just add it back to here. So and then once you saw that you had to copy paste code, this should scream for loop.
Yep.
So and so what I would expect from you if you were to improve is to immediately recognize these situations and then just immediately course correct, at least in your mind. And it really just begins by going back over what you've done and just seeing how much more efficient you can be with it. And one of the things I stress in the interview and the guide is how much more efficient can you be. And you saw like how I was able to take just your code and then just say, hey, wait a minute, instead of doing this, what if you did this? And then just slowly built into that compact form, right?
Yeah.
So that way the next time you do encounter something like this, you can immediately just jump to that state. So what I want you to do is actually just see how you can make your code more compact and more.
I think this would be a great way to practice. Actually, is like really sort of stress myself and actually do sort of a rehearsal like this. This is great.
It's like what I would advise also is that after a day worth of like after you do some problems, like let's say you did 4 to 5 problems, go back to the way you've written each solution, read it, and see if you understand it without even looking at the problem.
Okay.
Like even right now, let's do this exercise. Can you read your own code and understand it? Don't look at the
So it's so disgusting from the 3 recursion steps. No, no. Like I think the for loop would be much more instructive. Like yes, I just solved the problem, so yeah, I kind of understand what's going on, but I feel like the code could tell a much better story than it is.
Yeah, this goes to the whole thing of like self-documenting code. Like the code, because I know everyone says, "Oh, write comments." No, I would actually not. I don't like comments that much. I use comments as a last resort. The code itself and variable names should automatically tell me what I am doing because code gets refactored, moved around all the time, and the comments get left behind.
Yeah.
But if you have the code, you have the comment in it because it will explain its own functionality. So. And then what's right here, and what I'm doing right here, should be a little bit cleaner. I mean, granted, the variable names could also be changed, but it's a little bit easier to read because less code, but expresses the exact same thing. So that would be the exercise for you. Get faster, make your code more compact. But I think your basics are there. Actually, I like your approach. I think a lot of people should do what you do because at the end, you did get the right answer. You did. It's just a matter of cleaning that up and then making your time space and actually doing your time space complexity better. And one of the things that will help you is if you have readable code.
Yep. And this is a reasonable question to expect to be solved in 45 minutes or 25 minutes.
I would say 25 minutes. I think I would if I'm like in this current environment, I'm looking for top tier candidates. I'm expecting to solve this in 25, 30 minutes.
Sure.
And so your time space complexity analysis, the argument for that is you're only ever going to recurse 4 times.
Yeah.
So that means that so like you grab a chunk of 1, 2, or 3, right? And then you do that 4 times. But this is you're doing 4 times. But this is a constant amount of work, right? Because you're only ever going to grab 1, 2, or 3 items, right?
Yep.
And so this just eventually, so 4 times O of 1 is still O of 1.
Yep.
So that's your time complexity. Your space complexity is just holding the answer. Anything additional is really just this. Is just the combination here.
Yeah.
So then I would just argue that it's order 1 additional space because you're only ever going to hold 4 strings. Or 4 strings. So, and that's pretty much what you're doing too. Except you're deep copying it, but that's I'm going to ignore that for now. So.
Yeah.
I'm going to assume that garbage collection runs every single time, and that you don't need the additional space. So yeah.
Okay.
But yeah, this is how I would do it. Hopefully you kind of see how I went from your solution to a much cleaner solution, and this is something I'd like to see from you. I think if you had the 4-month runway, that's plenty of time. In fact, I think you might be ready in 2 months if you seriously practice and do everything right.
Yeah. I don't know. What is your time for me? You want us to end at? I think we're scheduled until 3, but what are your time constraints here?
You have me until noon, so I'm on Pacific Standard Time, so we have another 30 minutes.
Okay. Was there anything else you wanted to say? But before I got to a couple questions, or
not really. I think your approach is solid. You've shown that you definitely do practice. But I think I also want to point out one of the things that I'm surprised you didn't recognize this as a combinatorial or a subset problem. That's a pattern that they introduced in grokking, and I feel like you should have immediately recognized this, and you should have recognized the base skeleton for it.
Subset problems. Is there another way to do this where you?
What's it? It's your recursion case, and the skeleton for this, if I remember off the top of my head, is essentially just like so then you have your function, and then your your base exit conditions, which is and then you have your loop and then function and then substring.
Okay. Yeah.
It's like that, but then you can expand it out to whatever you want it to be.
Sure.
But you should be able to do this template off the top of your head, and that's the pattern that I'm talking about. Whatever that looks like to you is different. For me, I would fill this information out a little bit more, whether it's like index C's -1, index -1, index 0, yada yada yada.
Yeah.
Something like that. But yeah, look at the video of how I study. And that should give you some hints. But I definitely would go back over grokking just one more time, and practice writing these basics, and then move on.
So maybe just rewrite every problem in grokking.
I would say no. So the way I do it, if you watch my video, is I basically take the bare bones of those patterns, like take all those problems, get the bare bones of it, and rewrite it over and over and over again.
Oh, okay. You actually discuss your study approach in your YouTube videos?
Mm-hmm. Yeah.
Okay, cool. So I'll just watch all those. Awesome. That might cut down on some questions here, actually.
But yeah, feel free to ask them. You have me for 30 minutes.